You are now ready to construct your first confidence interval. We're going to be following the main 5 steps on how to construct a confidence interval. Notice I have them here below. The first step is to read the given information and label the following: X bar, S, N, and CL. Okay? So let's read the problem. A student records the repair cost of 45 randomly selected computers from a local repair shop where he works. A mean of $216.53 and a standard deviation of $15.86 are computed from the sample. Okay? So let's go ahead and stop there. We're looking at a sample size of 45 computers. The mean coming from this sample, notice it says computer from the sample. The mean is 216.53. So this is our X bar. Remember, X bar is the mean of the sample. And it also says that the standard deviation, computed from the sample, is 15.86. So this is the value of S. Now it says, assume that the population distribution is approximately normal. Determine the 98 confidence interval for the mean paired cost of all computers repaired at the local shop. Okay, so this 98% is the confidence level. CL is equal to 0.98. Okay? Now notice, we're going to be constructing this confidence interval to estimate the mean repair cost of all computers repaired at this shop. This here is mu. We're wanting to construct a confidence interval to estimate mu. Let's go ahead and follow our steps. You can go ahead and write the steps below. I'm just going to edit what I have here on my screen. I'm going to write the value of X bar here. I'm also going to write the value of S, the value of N, and the value of CL. The second step is to find the t-score corresponding to the confidence level. This is denoted as T corresponding to alpha divided by 2. On step 2, we're going to find the t-score corresponding to alpha divided by 2. So here I should really be writing corresponding to alpha over 2, which is denoted as T alpha over 2. We can go ahead and do this with a calculator, Google Sheets, or Excel. If you're using a calculator, you're using INVT. If you're using Google Sheets or Excel, you're using equal_t.inv. Now we need two values here, right? We need the area to the left of the c-score we're trying to find. We also need the degrees of freedom. Same thing here below. We need the area to the left of the t-score we're trying to find and the degrees of freedom. So we need to find those values. Okay? Let's go ahead and visualize what we have here. We are looking at the t distribution composed of t-scores. We're wanting to capture the middle 98% of the area. That is the area equivalent to 0.98. We are trying to find the t-score here on the left. We know that it's going to be a negative value. Again, you can also find the t-score here on the right, but it's easier to just stick with finding the t-score here on the left. You might be wondering why. Well, because the area below this t-score is always going to be alpha divided by 2. So here we need to find alpha divided by 2. What's our alpha value here? Well, alpha is equal to 1 minus the confidence level, so 1 minus 0.98. So our alpha value is 0.02. Now, what is alpha divided by 2? Alpha divided by 2 is equal to 0.02 divided by 2, which is going to give us 0.01. So that is the area that we have on each of the tails. Alpha divided by 2 is the area to the left of the t-score that you're trying to find. So here, the first value that you enter on either one of these two functions is going to be 0.01. Now, the second value on both of these functions is the degrees of freedom. Remember, degrees of freedom is n minus 1. Here we have n equal to 45. So the degrees of freedom is 44. Same thing here below. Again, both functions are wanting the area to the left of the t-score you're trying to find and the degrees of freedom. So go ahead and try this on your calculator, Google Sheets, or Excel. Here I'm using the value that I got from the calculator. If you're using the value that you got from Google Sheets or Excel, you're still going to end up with the same confidence interval, because once we round, and we usually round to 2, 3, or 4 decimal places, those last few values are not going to make a difference. Okay? So now that you have the t-score, you are done with the hard part, because in step 3, we're going to be computing the error. We have a formula for the error. We're going to take the formula, and instead of writing t alpha over 2, we're going to replace this value with the t-score that we found. Let me go ahead and copy that t-score. Again, this value here, the t-score corresponding to alpha divided by 2, is the t-score that we found. Now here, instead of writing s, let's go ahead and write the value of s that was given to us. S is 15.86. Okay? Then we're dividing by the square root of n. Instead of writing n, let's go ahead and write the value of n, which is 45. And now you just need to enter this expression into your calculator. You can even use your phone calculator, a basic calculator, any type of calculator. Let me just use the TI-84 calculator since I have it on my computer. Let me enter the value of the t-score. So we have negative 2.414134326. Then we're going to multiply by 15.86 divided by the square root of 45. Press enter, and here you have it. This is the value for the margin of error. So coming back to our notes, we're just going to go ahead and write that value. Once you have the margin of error, you're ready to construct the confidence interval. When we construct the confidence interval, you can think of this as 2 steps. The first step is to take x bar minus e. Our x value is 216.53, so that's our x value, minus the error. The error is this value here. So let me just copy it. We're going to need to enter this expression on the calculator. That's going to be our first step. Our second step is to take x bar plus e. Again, our x bar value is 216.53, and then we're adding the value for the error. We have the value of the margin of error. We're also going to need to enter this expression on the calculator. Okay? So go ahead and do that. Take 216.53 minus the value of the error, see what you get. And then on another line, take 216.53 plus the value of the error. What are you getting? Here are the values that you should be getting when you enter this on a calculator. And here, we're not being asked how to round, so we're just going to be rounding to 2 decimal places. When you write the confidence interval, you're always going to want to enter the lowest value first. So in this case, the lowest value is 210.82. Again, I'm rounding to 2 decimal places. Okay? And then you enter the largest value out of the 2. In this case, it is 222.24. And here you have it. This is your confidence interval. Here, you're saying the mu is inside this confidence interval. We're saying the mu is between $210.82 and $222.24. Now, the last step here is to write a sentence to interpret the confidence interval. I'm going to copy the sentence that we have in page 2. And here, I'm copying this sentence because I want to emphasize how you can use this sentence to interpret a confidence interval, regardless of what situation you have. Okay? So here we're going to write, we estimate with 98%, right? That is the value of our confidence level. We estimate with 98% confidence that the true population mean, right? Mu. And now we need to describe mu. What is mu? Well, let's go back. We actually have a sentence that describes mu. We estimate that the true population mean repair cost for all computers repaired at the local shop. That is the description of mu. Okay? So let me copy that sentence there. Okay? Here we're saying we estimate with 98% confidence that the true population mean repair cost for all computers repaired at this local shop is between, and this is where we enter the values that we have for the confidence interval, 210.82 and 222.24. Okay? Now we need to include the units. The units here are dollars. And there you have it. Again, we're saying we are 98% confident that the population mean repair cost for all computers, that is mu, is between or within our confidence interval. That is what we're saying in this sentence. Now, one thing to mention here is that when I'm explaining problems, I go into detail to make sure that I reach different types of learners. Now, if this was on your exam, you're not required to show me the curve and how you find the t-score. Okay, so you wouldn't have to show me this. You would also just need to show me whether you're using a calculator, Google Sheets, or Excel. Okay, so if you're using just Google Sheets and Excel, you don't have to show me this. Perhaps you wouldn't have to show me step 1. That's a step that you always have to take, right? Summarize the given information. So most of the time, I don't ask you to show me this. Okay, so again, on an exam, you would have to show me how you got the t-score, how you got the margin of error, and how you constructed the confidence interval. Okay? You should also be ready to write a sentence that interprets a confidence interval. I'm mentioning this because sometimes students look at these problems and they think that they're way too long, and they think that it's going to take them a long time to construct a confidence interval. It shouldn't take you that long. I want to emphasize that this would be the work that you would have to show me if this is on one of your activities or on your exam.